Hello everybody, today I'm going to explain the static keyword using Java. Static is a keyword. It modifies a variable or method so that it belongs to the class rather than any specific object. We see the static keyword within the main method. When you modify a variable or method with the static keyword, static is used to create utility methods or other shared resources. Let me give you a demonstration. We're going to create a new class. Let's go to File, New, Class. We'll create a friend class. We will create some friend objects, because you're lonely. Let's say that all friends will have a name attribute, string name. We need a constructor. It's the same as the class name, parentheses, curly braces. When we construct a friend object, we have to pass in a string of name. We will assign this object's name attribute equal to the name parameter that we receive. Let's construct two friends. We'll say friend1 equals new friend. But we have to pass in a name. Pick a name. My default is SpongeBob, because most people know who SpongeBob is. If I was to output friend1's name, then it should be SpongeBob. We just want to be sure that it works. Yes, it does. SpongeBob. Now, going back to our friend class, let's say we would like to keep track of how many friend objects we create. Well, that could be an attribute. Let's say we have an integer of num of friends, meaning number of friends. Whenever we create a friend object, we will increment number of friends by 1. Num of friends plus plus. So going back, let's output friend1's number of friends attribute, num of friends. So this should be 1. Yep, num of friends is 1. We have one friend. But what if we create a second friend object? I'll just copy this line of code, paste it, change friend1 to friend2. We'll pass in a new name, let's say Patrick. We'll print friend1's number of friends and friend2's number of friends. How many friend objects have we created? We have created 2, but what's the output? Well, it's 1 for both. Here's why. Each friend object has their own copy of the number of friends variable. We're incrementing each copy of number of friends by 1. When we create the object of friend1, we're incrementing its attribute of number of friends by 1. Same thing applies with friend2. When we create friend2, friend2's number of friends is 0, and we're incrementing it by 1. What if we would like to keep track of the total amount of friends that we created and store it within one variable? Well, there is a way we can do that, and that is with the static modifier. So going back to our friend class, we're going to precede the data type of this attribute with the static modifier, static int number of friends. Rather than all objects, all friend objects, having their own copy of number of friends, they're all going to share 1. So going back, let's print number of friends now. It's 2. We have 2 total friends. If I was to create a third friend, friend3, friend3 will be Squidward, and then I'll output friend3's number of friends. We have 3 total friends. We are receiving a suggestion. When accessing a static variable or calling a static method, it's actually best to do so through the class itself, rather than any object created from that class. Instead of saying, friend1, then accessing the static member, we will instead use the name of the class, in this case, friend. It's better for clarity to access a static member by the name of the class itself rather than any object, because you and other developers will know that this is a static attribute or method. To display the static variable, we would want to access it by the class name, then access that static attribute. How many friends do we have now? 3. Let's create a fourth friend. Friend4 will be Sandy. Then display the number of friends we have. Now we have 4 friends. Going back to the friend class, it's as if all these objects are sharing the same variable, but rather than any one object having ownership of this variable, rather the friend class owns it, and all objects have access to it. Methods can also be modified by the static keyword. We will create a static method that doesn't return anything. The return type is void. This method will be the showFriends method. We'll just output the following. We'll output you have plus. Normally, when you access an attribute, you type this dot the name of the attribute, such as, name. If you're working with a static attribute, you don't need this. For example, this dot number of friends, you don't need this. We even have a warning here that friends.this cannot be referenced from a static context. If you're working with a static attribute, you don't need this. This refers to the object you're currently working with, but since this attribute belongs to the class, we don't need this. You have your static attribute of number of friends, then the words total friends. To call a static method, type the name of the class, in this case friend, dot the name of the method, show friends. You have 4 total friends. Let's create another friend, friend 5. Friend 5 will be Gary. Friend.showFriends. You have 5 total friends. Another place in which you see static members is through the math class. For example, let's say you would like to round a number. You would type the name of the math class, math.round, and you can round a number. Round is a utility method. We access it through the class name of math. You don't need to go ahead and create a math object, such as math1 equals new math, and then access it through this object. That would be silly. Round is a static method. It behaves as a utility method. We can access it through the class name, and we don't need to create any math objects, because that's stupid. And to prove this, let's go to the math class. I'm going to hover over math, jump to source. Here's the math class, and let's find the round method. I'm going to do a search for it. Here's the round method. So round is a method, and we have that static keyword. Round is a utility method for the math class. We can access it through the name of the class. All right, everybody, so that is the static keyword. It modifies a variable or method so that it belongs to the class, rather than any specific object. It's commonly used for utility methods or shared resources among objects created from that class, such as the number of friends. All those friend objects share the same attribute, rather than each of them having their own copy. And well, everybody, that is the static keyword in Java. What is going on, people? Today we got a very important topic to discuss today, and that is inheritance. Inheritance is where one class inherits the attributes and methods from another class, much like how a child can inherit traits from a parent. Well, in programming, we could do something similar. One class, a child class, can inherit traits from a parent. Here's an example. We're going to create a few classes, but we'll start with a new class of animal. Let's go to new, class. I will create an animal class. What do animals have? Let's say that all animals are alive. They will start by being alive. Is alive. Let's create a constructor of animal. I will set is alive to be true when we construct a new animal object. But not only are all animals alive, all animals can eat. They will have an eat method. Void eat. We'll print something like the following. The animal is eating. Easting. Eating. That is good enough for this class. So what we're going to do is create 2 more classes. File, new, class. We will create a dog class and a cat class. Dogs and cats are types of animals. Our animal class will be the parent. The dog and cat class will be its children. In order for a class to inherit all the attributes and methods from another class, after the class name, you will use the extends keyword, then specify the parent class. Dog extends animal. Our dog class will inherit all these traits, these attributes and methods, from the animal class. The cat and dog class don't have anything within them. Let's see if they actually do have these attributes and methods, even though there's nothing within them. Let's create a dog object. Dog equals new dog, and a cat. Cat equals new cat. Let's print our dog's is alive variable. Is my dog alive? I sure hope so. Cat dot is alive. Look at that, they're both true. They should also be able to eat. Dog dot eat method, cat dot eat method. The animal is eating, the animal is eating. Even though these classes of dog and cat don't have anything within them, since they extend to the animal class, we're specifying that the animal class is the parent. The cat and dog classes are the children of the animal class. They inherit all these attributes and methods from its parent of animal, even though they don't have anything within them. This isn't as useful if you only have a few classes, such as 2, because, you could just copy and paste all this code within each, and then just change the constructor. But imagine if you had hundreds of classes, hundreds of children. You'd have to do that for hundreds of classes. But not only that, if you have to make any changes to say, this animal is eating, you'd have to make that change for hundreds of classes. And we are repeating ourselves a lot. It'd be a lot easier if we could just make that change in one place. If we have to change the to this, all of the children classes will inherit this updated method. We're following the dry principle. Don't repeat yourself. We're writing the code once and just reusing it. All the children classes will inherit this updated method. But not only that, each child class can have their own unique attributes and methods too. Let's say that all dogs will have 1 life. Int lives equals 1. They will also have their own unique speak method. Void speak. When our dog uses the speak method, let's output the following. Let's say the dog goes woof. Then within the cat class, cats will have 9 lives. And they can speak, but they will say something different when they speak. Let's output the cat goes meow. Going back, let's output our dog object's lives. How many lives does our dog have? Same thing applies with our cat. Cat.lives. Our dog has 1 life, our cat has 9 lives. They also have their own unique speak methods. Dog.speak, cat.speak. The dog goes woof, the cat goes meow. There's also the concept of multi-level inheritance. We'll create a new class to serve as a sort of grandparent. A child class will inherit from a parent will inherit from a grandparent. So let's change this program around a little bit. We're going to create a new class. File, new, Java class. We will create a class of organism. Animals will extends the organism class. Let's cut our isAlive variable and the constructor. If you inherit from the animal class, you will get an eat method. If you inherit from the organism class, you are alive, and that's it. But we need to change the constructor. Animal inherits from organism, dog and cat inherit from the animal class. So from the perspective of our dog and cat class, the organism class is, you could say, a grandparent. Going back to our main Java file, let's take a look at our isAlive variables. Dog.isAlive. Same thing with our cat. Cat.isAlive. Yes, our dog is alive, and our cat is alive. Let's take this a step further. Let's create a class of plant. Plant is going to inherit from the organism class, because plants are a type of organism, but they're not related to animals. Let's create a new class of plant. Let's say that if you're a plant, you get a method to, well, plants don't eat, but they can photosynthesize. photosynthesize. I think I spelled that right. Probably not, but who cares? If you're a plant and you photosynthesize, then the plant absorbs sunlight. Hey, this is Bro from the future. I forgot to extend the organism class. So let's take care of that. Heading back to our main Java file, let's create a plant object. Plant equals new plant. Our plant object should have an isAlive attribute. isAlive, which it inherits from the organism class. That's true. And plants can photosynthesize. Plant.photosynthesize. The plant absorbs sunlight. It's kind of like we have a whole family tree. Dog and cat inherit from animal, animal inherits from organism, and plant inherits from organism. But animals and plants aren't related. They're siblings, but they're not the same. Going back to our main Java file, let's see if our dog has a photosynthesize method. Dog.photosynthesize. Looks like they can't. We do not have a photosynthesize method for dogs. They do not inherit this method because they're not related to plants. Alright everybody, so that's inheritance. It's where one class inherits the attributes and methods from another class. A child class will inherit all the attributes and methods from a parent class. Parents can also be considered children too, and inherit from a, let's say, grandparent class. You just have to use the extends keyword. And well everybody, that's inheritance in Java. Yo, so let's get started. Today I gotta discuss the super keyword. Super just refers to the parent class when using inheritance. A child class is also known as the subclass. The parent class is also known as the superclass. Super just means parent for all intents and purposes. The super keyword is used within constructors and method overriding. Method overriding is a whole nother topic that we'll discuss. We're more focused on constructors in this topic. We use the super keyword to call the parent constructor to initialize attributes. Let me give you an example. We'll be creating a few different classes. Let's go to File, New, Class. We will begin by creating a class of Person. Person will be the parent, the superclass. Let's say that any person object has the following attributes. They will have a string of first, meaning first name, then string last, meaning last name. We'll need a constructor. It's going to be the same as the class name, person, parentheses, curly braces. When we construct a person object, we will need to pass in the following arguments: a string for first name, first, and a string for last name, last. This object's first name attribute, this.first, equals the argument that we receive for first. Same thing applies with last. This.last equals the argument we receive for last. And then we'll create one method in this demonstration. This method won't return anything. We will name the method showName. All we'll do is output the following: this.first plus a space plus this.last. Okay, let's test this class out. Person equals new person. But we do have to pass in a first and last name. I've already used SpongeBob for too many examples, so let's mix it up. This time I'll pick Harry Potter. Or feel free to pick a different franchise that you like. So, one person from Harry Potter is Tom Riddle. We have a person object with this first name and this last name. First, last. Our person is going to have a showName method. Showname. Then call it. There we go. There's our person object's first and last name. Tom Riddle. Our person class will be the parent class. We'll create a few other classes to inherit from this person class. We're going to create a class of student that's going to inherit from the person class. The student class will inherit these attributes and methods. Let's create a new class of student. Student will extends the parent or superclass of person. Since student is inheriting from person, student is going to have a first and last name already, and a show name method. What other attributes does a student have that a person might not? Well, students have a GPA, a grade point average. We'll declare that as an attribute, double GPA. We're going to create a student constructor. Let's say that when we create a student, we need to pass in a string for first name, string first, string last, and double GPA. What's their grade point average? Now, rather than assigning our first and last name within this constructor, such as this.first equals first, this.last equals last, and this.gpa equals GPA, we are receiving a warning. There is no parameterless constructor available in person. We're not able to assign these attributes of first and last within the constructor for student. This is because student inherits from the person class. Since the constructor of our parent requires a first and last name, we have to pass these arguments to its parent of person. How we can do that, going back to the child class, we're going to be using the super keyword. Any arguments that the parent requires, we have to send the parent these arguments from the child constructor. And how we can do that is use the super keyword, and then pass in those arguments of first and last. And now Java is happy. Super just refers to the parent. Imagine that we replace the super keyword with person. Think of it like that. And now this should work. Going back to our main file, we should be able to create a student object. Student equals new student. We have to pass in a first name. First name will be Harry. Last name will be Potter. Then we have to pass in a GPA because our student constructor requires it. Harry Potter has a 3.25 GPA, let's say. Our student object should have these attributes, this method, and this attribute from the student class of GPA. Let's test it. Student.showName. This student's name is Harry Potter, and they should have a GPA. Let's print student's GPA attribute. 3.25. But not only that, let's create a method to display their GPA. Within the student class, we will create a method that doesn't return anything. It will be showGPA. We will output the following. Let's say this.first plus a string, apostrophe S. So Harry's GPA is plus this.gpa. Let's take our student object, call the showGPA method that we have declared. Harry's GPA is 3.25. Let's create one more class. We will create an employee class. Class employee. Employee will inherit from the person class. Employee extends person. Since employees aren't studying, they're not students, they instead get a salary. We will create an integer attribute of salary. And then we need that constructor for our employee object. All employees will require the following arguments. A string for first name, string first, a string for last name, string last, and an integer for our employee's salary. I will attempt to assign these attributes for our employee. Again, it's not going to work, but let's try it. This.first equals first. This dot last equals last. This dot salary equals salary. Again, we're receiving that warning. There is no parameter list constructor available in person. Since employee extends person, and our person constructor requires a first name and a last name, we have to send our person constructor these arguments first and last. So again, going back to our employee class, we will call the constructor of our parent using the super keyword, and then passing in those arguments, first and last. Let's create a method within our employee class, void show salary. Let's output the following. We'll say this dot first, this person's first name, apostrophe s. We'll create the employee of Hagrid. Their salary is, pick unit of currency, I'll pick American dollars, plus this dot salary. Now we'll need to construct an employee object. Employee equals new employee. We have to pass in a first name, a last name, and a salary in order to construct an employee object. We're going to pick Hagrid. Hagrid's first name is actually Rubius. Last name, Hagrid. Hagrid's salary will be $50,000, let's say. All right, let's take our employee, call its show salary method. And there we go. Rubius, also known as Hagrid, Rubius' salary is $50,000. In conclusion, super refers to the parent class. Student and employee inherit from person. Since the constructor of the parent of person requires a first name and a last name, any children objects that we create, we have to call the constructor of the parent and pass in those arguments to satisfy Java. If the parent didn't require these arguments, then you wouldn't need to. And well, everybody, that is the super keyword in Java. What's going on, people? Today I'm going to discuss method overriding using Java. Method overriding is when a subclass provides its own implementation of a method, rather than use one that's inherited from a parent. It allows for code reusability, and you can give specific implementations of a method. Let me give you a demonstration. We'll be creating a few classes. File, new, class. We will begin by creating a class of animal. Then a new class of dog. A class of cat. Then finally, a class of fish. Dog, cat, and fish are going to extend the animal class. After the class name type extends animal. So let's do this with cat and fish. The dog, cat, and fish classes are all children of the animal class. Animal class is the parent class. There's not a lot we have to write with this example. If a child class inherits from the animal parent class, they will inherit a method to move. Let's define a method of move. All we'll say is, this animal is running. We can keep the dog, cat, and fish classes empty for now. So going back to our main Java file, let's construct a dog object. Dog equals new dog. A cat object. Cat equals new cat. And a fish. Fish equals new fish. All three of these animal objects, dog, cat, and fish, should have a move method. Let's take our dog, call its move method. Same thing with the cat and the fish. Cat.move method, fish.move method. Currently, when we run this program, we get the following output. Our dog is running, our cat is running, and our fish is running, but fish don't have legs though. They can only swim. The move method that the fish class inherits isn't appropriate for that class. This animal is swimming would be more appropriate. So why don't we do this? Within the fish class, why don't we do some method overriding? Specifically for the fish class, we will create a unique move method only for this class. We will define a new move method where we will say this animal is swimming. However, it is good practice to add this annotation of @override so that you and other developers know that this method is being overridden. Our fish class does inherit a move method from its parent of animal. If you have the same named method defined in a child class, you'll use that one first. It has precedence. Going back to our main Java file, let's call the move method for our fish. Our dog is running, our cat is running, but our fish is swimming. Within the fish class, we have overridden the move method. We have given a specific implementation for this method just for this one class. The cat and dog classes will use what's inherited from their parent. Not only is it good practice to add this annotation of @override, but let's say that you misspell this overwritten method. Rather than move, let's say moves, even though it should be move. We're receiving a warning that this method does not override the method from its superclass, its parent. If you didn't have this annotation, you may not notice that you misspelt this method and you're not actually overriding it. Adding the @override annotation provides a system of checks and balances when overriding method. This error will go away once we actually are overriding a method. Alright everybody, so that is method overriding. It's when a subclass provides its own implementation of a method, rather than use one that's already defined. It allows for code reusability, and you can give specific implementations of a method. We'll be seeing method overriding again with the tostring method coming up in a future topic. And well everybody, that is method overriding in Java. Hello everybody, today I gotta explain the tostring method using Java. The tostring method is inherited from the object class. Whenever you create an object, behind the scenes, the object class is a superclass. The tostring method is used to return a string representation of an object if you were to output it directly using system.out.println. The default behavior of the tostring method is that it returns a hash code as a unique identifier for that object, but it can be overridden to provide meaningful details, which is why we've learned about method overriding in the last video. In this demonstration, let's create a new class. File, New, Class. We will create a car class. Let's say that all cars should have the following attributes: a string of make, who manufactures the car; a string of model, what's the model of the car; int year for the year; and string color for the color. We'll need a constructor, and then we'll assign these attributes. We have a string of make, a string of model, an int of year, and a string of color. Then we'll assign these attributes. This.make equals make, this.model equals model, this.year equals year, this.color equals color. That looks good enough for now. Going back to our main Java file, we'll construct a car object. Car equals new car. But we have to pass in the details for our car constructor. Our car constructor requires a make, a model, a year, and a color. So pick a car that you like. I like Ford Mustangs. I'll pick a Ford Mustang. The make will be Ford. Model will be Mustang. I need a year, 2025, and a color. I'll pick the color red. Car is an object. If I were to output my car object directly using system.out.println, here's what you'll see. If you output your car directly, technically you'll be given a hash code, a unique identifier for that car object. Hashing is kind of an advanced topic that I don't want to introduce right now, but typically with hashing, it's a unique identifier that uses the object's memory address to calculate a hash. You don't need to know any more than that right now. But wouldn't it be useful if we were to print our car object directly, we were given the details of the car? Normally what we would have to do is output something like this. This is if we wanted to output the details of the car. We could say something such as car.color, that would be first, plus a space character, plus car dot, what should be next? Let's say the year. Color, year, then make and model. Car dot make plus a space plus car dot model. This print line statement is giving us meaningful details of this car object. This is the output. Red 2025 Ford Mustang. It would be nice if we were to print our car object directly using print or print line. We could be given these details instead. Well, we can do that with method overriding. Going to our car class, we will be overriding a method. We need the @override annotation. We do need this keyword of public. This is a publicly accessible method. The return type is string. The name of the method is toString. Everything within this print line statement, we're going to cut and delete this print line statement. Going to our car class within the toString method, we have to return a string because we set the return type to be a string. We promised that we would return a string. Let's paste all the details of that car. We'll need to replace car with this. This refers to the object we're currently working with. Then add a semicolon to the end. If we were to print our car object directly using this print line statement, or a print statement, or even printf, instead of that hash code, we're instead given meaningful details of that car that we've customized. The car's color, year, make, and model. We have overridden the toString method that's normally available to all objects. Let's construct another car object. Let's rename car as car1. We'll have car2 equals new car. Pick some different details for a car. I will pick a Chevrolet Corvette. The year will be 2026, and the color will be blue. I'll print car1, then print car2. Here's car1 and car2. Car2 is a blue 2026 Chevrolet Corvette. Alright everybody, so that is the toString method. Objects inherit from the object class. The object class does have a toString method, but it can be overridden so that when you print an object directly, you can display meaningful details, such as the details of that object, instead of displaying a hash code if you were to print the object. It's pretty useful at times. And well everybody, that is the toString method in Java.